Okay, so now that we have understood the input layer, input embeddings, and the positional encodings, how does the transformer decide which word matters the most to understand the entire sentence? When I say, I like Hyderabadi chicken biryani, how does the model know that eating relates to biryani more than I? So this kind of thing happens in the multi-head attention. So let's try to understand the multi-head attention now. So the answer to the question on how does the model understands that eating relates to biryani more than I, the answer is self-attention. The secret behind how transformer understands the relationship between the words is by self-attention. But what if one layer isn't enough? What if we need multiple perspectives? And that is what multi-head attention does. Now imagine I'm reading a sentence, I like eating chicken biryani. Each word in the sentence has a relationship with other words. For example, eating is strongly connected to biryani, and I is connected to like but not as much as with biryani. Okay, so how does a transformer learns these relationships? It uses something known as self-attention. This self-attention will assign important weights to each word relative to every other word in the sentence, something like shown in this table. Now, I've done it just for biryani because I'm a very lazy person, but you will have these kind of relations or these kind of percentages assigned to each word to attending to itself. And that's why this particular method is known as self-attention. And this is how exactly does a self-attention work. Now, let's try to understand step by step on how attention works. Every word in the sentence is converted into three vectors. Number one, query, the word asking for information. The key, the word providing the information. And then the value, the actual content that is passed forward. Now, mathematically, we compute the similarity or the dot product between the query and the key, and the more similar the query and key is, the higher is the attention score which is provided over here. Now, um, again, we apply the higher would be the attention score. Then we apply softmax function to normalize these scores into probabilities. And finally, we multiply these attention weights with values to get the contextual representation. The formula for the attention is given by something like this. So the formula of attention is given by something like this, where you have a softmax which is applied to query key vector and is multiplied by its value. Sorry, I forgot. By its value. Okay. Now, the dk over here is the dimension of the key vector. Let's take an example. So, the attention in our sentence, which is I like eating chicken biryani, the attention score to the eating would be the attention score of the word biryani to eating would be something around 11% over here. And then similarly, the biryani attending to the word, the Hyderabadi attending to the word biryani would be something around 22%. Similarly, 39% to chicken and 23% to the biryani itself. Now, here the biryani gets high attention to analyze the word eating, Hyderabadi, and chicken itself. So this is how the attention mechanism works. Now, imagine if we had only one attention mechanism. What if it focused only on the word meaning and ignored the word's position? This is why transformer use multi-head attention instead of just single attention function. We use multiple attention heads in parallel. Now, how does multi-attention head work? Each head learns from the different aspects of the sentence. One head might just... So now let's try to understand the multi-headed attention. Why one attention mechanism isn't enough? Now imagine if we have only one attention mechanism. What if it gets focused just on one word meaning and ignores the word position itself? This is why the transformer has multi-head attention. Instead of just single attention function, we use multiple parallel attention heads. Now, how does these multi-headed attention works? Each head learns from a different aspect of the sentence. One head might focus on grammatical structure, the other might focus on semantic meanings, and the other might track long-range dependencies. Each head will have its own query key value matrix. Instead of just one query key value set, we'll have multiple. And then they are combined at the end of it to perform richer representation. So understanding I like eating Hyderabadi chicken biryani, one head would focus on verbs which connects eating to biryani, The other head would focus on recognizing entities, where it recognizes Hyderabadi chicken biryani as food. And the third head might track the positions, which ensures that eating comes before biryani. So the formula of the multi-attention head is nothing but concatenation of all the heads into the word vectors itself. Now, let's take a real world analogy, finding a book inside a library. This will help us understanding the key values. This will help us in, this will help us in understanding the key value query pair in a much more detail. Now, let's think of self-attention as searching a book in a library. The query over here would be, I need a book on AI engineering, where I create a query that I need a book on AI engineering, right? And the key with the highest similarity, or the dot product, gets the highest attention, right? And the library assistant or the transformer fetches the most relevant value, which is most relevant book to the content that I'm looking for. So the example of attention scores over here would be, the deep learning basics might have an attention score of something, a book named Deep Learning Basics might have an attention score of zero point 0.2. AI engineering guide would be something of 0.9, and a computer science introduction inside this library would have an attention score of say 0.3. And then the transformer would select something like AI engineering, say AI engineering book, which had an attention score of around 0.9. The transformer will select the AI engineering book as compared to other books, as it is the most relevant one. Now, let's try to have another example where we have an AI expert team selection using dot product attention. So if I could just drag it over here. Now, suppose that I need help in developing an AI product. I have 4 experts with me, with each having different skills. The transformer needs to decide, or the teacher or the product manager needs to decide, who is the most relevant one. So the expert profiles that I have with me is Roshan, who is a doctor, and Nashit, who is an ML engineer. Then we have Omar, who is a computer science expert, and we have Alina, who is an linear algebra specialist. Now the transformer will assign Nashid the highest weight, around 59% of the contribution, since ML engineer would be the most relevant person who would be able to help in developing an AI product. So this is how you will have a key query and a value percentage contribution to the value pair, where the contribution is taken by dot product between the query and the key dimensions itself. So this is how the entire multi-head attention works. I hope that it is clear. So now each context formed might be see different aspects of the tokens, such as the one might see nouns, the other might see positions, and etc. Now, once you have these context-aware embeddings from your multiple heads, so the first head might look at attention. The first head might just be looking into the verbs in the sentences. The second head might be just looking into the adjectives and so on. And then you will finally consolidate all the context from all the heads that you have, and you will have your final context-aware embedding. Now, this particular context-aware embedding. So until now, all the transformations that we have done, the positional encoding transformation, the word embedding transformations, and the multi-head attention itself, you will realize that everything that we are doing over here is basically linear transformation. So you understand from the deep learning that we need some non-linear transformations as well to get non-linear to capture the non-linear relations between the words, right? So that is what we'll learn in the next lecture, but this is exactly how the multi-head attention works. Now, if you liked it, do give it a thumbs up and share it with someone who might need it. Thank you.